All right, we're on to the last part of this review. So now we are talking about inverse trig ratios. So this was the one where the only one where you're solving for an angle. So if you look at all the problems here, so you can see that the x is now in the angle, it's not a side. So if you're solving for an angle, you know this is the method you're going to use. This is the method that requires the least amount of actual algebra, but it looks a little funky, so just pay attention to how it looks. But yeah, it's actually very simple once you get it set up. So it starts off the same way where, okay, we have a right triangle. We're referencing an angle. Okay, there's the angle that we want to find. So we're going to label our O, H, and A from that angle. So from this angle X, directly across the side that's furthest away from it, this side is touching it, this side is touching it, it's the one that's not touching this angle. That is our O. Still got some people confused about that. Then the exact same thing. So the hypotenuse, just like we had to do in the Pythagorean theorem, that is our H. It's directly across from the right angle. This side down here, the third side, that's our A. Okay. That's important because we're trying to solve for this angle. We're still going to use like sine, cosine, tangent, those ratios. So we still got to think about our all-important SOHCAHTOA. A quick tangent, just as a review for a lot of people that are still, and it is a lot of people that are still stuck on this, what SOHCAHTOA really is. It just comes from this, what is sine? Let's say we're talking about x. What is sine of x? Well, that is whatever O over H is, okay? What is cosine of x? Well, whatever A over H is, that's cosine. And what is tangent of x? Well, that is just O over A. So you have these three ratios, and that's where the SOHCAHTOA comes from. SOHCAHTOA. So it's a way of memorizing it. So sine is O over H, cosine is A over H, tangent is O over A. So that's important because which of the three do we need to use? Well, I'm looking at this problem, thinking about what they gave me. They gave me the O and they gave me the H. Okay. Well, which one uses O and H? Well, sine. So, and you could look here, okay, sine. So that's how I know I need to use sine in this problem. Okay, it's different in every problem. This problem is sine because they gave me the O and the H, and this one uses O and H. So we're going to go ahead and write our problem. So it does look a little different now. So instead of it being sine of x equals O over H, remember it's the opposite of that. So now we use this little -1. That just represents the inverse. It's just a way of notating it's the opposite. But so now instead of the x being in parentheses here, we put the O over H. So O over H, 7 over 25. And now, we can close our parentheses, equals, well, instead of it equaling the O over H, it's going to equal the x. So it just flipped. And that's great because x is already by itself. So we don't need to do any work to do that. All we need to do is plug this into our calculator, sine inverse of 7 over 25. So let's go ahead to our calculator, somewhere here. Thought I had it up. I guess not. Okay, hold on. Let me get you guys a calculator. You can see how I'm going to type this in. Sorry, it's taking a second. There we go. Okay, so it's going to look just like this, sine inverse of 7 over 25. And most of the time, the way you do that is you're going to hit second. Now, there's no second button on this calculator, so it's going to be a little different. So if I hit this function, it's going to be sine inverse of 7 over 25. So let's go back to our main, 7 divided by, oops, make sure to type in right, 7 divided by 25, and we get 16.2, and it actually rounded up to 16.7. And I want you to use the degrees, so 16.7 degrees.